Hi. Thank you so much for joining the session. I'm pretty sure you will enjoy it, or I hope you will enjoy it. I want to start with turning on my presenter, sorry. And then I want to start with a question. What are shared secrets? So basically, how I see it, shared secrets are secret things that you, your team, and or your servers have to know. And most modern web applications do integrate with some services one way or another, like databases, other web services, or third-party APIs. And often enough, you will need something like credentials, API tokens, certificates, you get the idea, to establish a trusted connection to one of those services. Handling such secrets in a team can be a challenging and sometimes even intimidating task. And what we have seen in recent news, all over, even like very professional places, it happens that tokens get leaked because they're committed to GitHub, like all these news you see everywhere. So this gives us an idea of how hard this challenge can be, even for large companies. So today, I want to take a look into some directly applicable techniques that we can use to make this task not easy, but much easier. Traditionally, there are several approaches for handling secrets in an application. And the oldest one is having a constant in your source code. And I mean, to be honest, this immediately fixes some problems. For example, it helps you keeping secrets in sync inside of your team, right? Whenever someone checks out the source code, this person immediately has access to the latest and shiniest secrets, which also makes it not a very secure option. First of all, as I mentioned, everyone who has access to source code will, by definition, have access to the secrets. And furthermore, stuff like key rotation can become really tedious, because for changing a password, you will have to commit and test your changes. You have to deploy it, push it, deploy it. So you really attach key rotation to your life cycle of your source code. And besides that, it can become really hard or quite impossible to deploy that code to more than one location. Let's say you want to run it in production, development, and probably a third staging environment. You would have to use the same secrets everywhere, which probably is not a good idea. So while it fixes synchronization, it's not the best option. An evolved alternative to this could be the storage of secrets in configuration files. And this solves the pending issue of having clear text in your source code, right? There's no clear text in your source code anymore. But now, synchronization is gone, right? If I don't check in that file, which I shouldn't, then if someone checks out my source code, no secrets, it's not runnable, how do I get these files? So you need a way, when it changes, to distribute that change to team members and to deployments. So you still need a way to distribute this file in a secure and understandable fashion. Besides that, there's an unencrypted file laying around on your immediate file system on the server or on your local machine, which can become a problem. You can forget it. It's just kind of weird that there's a file lying around with all the important stuff in it. So to completely get rid of immediate or actual files in your deployment for handling secrets, you can use a trick which has been recommended by 12-Factor App, that is, move everything into environment variables that should really not be in your application, like your configuration or your secrets. An approach like this will keep the clear text secrets out of your source code, and away from your immediate file system on your deployed servers or on your local machine. In addition to that, configurable deploys is as easy as it can be, right? You can deploy the same code, 2 different environments, you change the environment variables, it's easy as that. And most modern deployment containers, be it Kubernetes or what have you, they all support, in a way, configuration via environment variables. But nevertheless, it still leaves you the burden finding a way to distribute that password throughout your team and your deployments. That problem itself is not solved by this. So all 3 approaches seem like a trade-off. You either have to decide between the ability to synchronize after rotation or the safety of the storage. You put it in a table like this. It's kind of the constant in your source code is super easy to sync. It's nice, secure, and not flexible. The environment can't be deployed to more than one location. The config file, on the other hand, has no syncability built in, but it's definitely more secure because the constants aren't in your source code, and it's much more flexible because you can provide different configuration files for different deployments. The environment variable version is also not syncable. It's probably as secure as the config files. The most important aspect is it's not in the source code. But I would say it's even more flexible because configuration is much easier. So what we're still missing is a way to synchronize the secrets in your team and to your deployments. So what we want to have is something like a shared password store that can be synchronized, which does not rely on a shared password, like a well-known shared password. We all know these passwords in our teams, and ideally we want to get rid of those. So before we can look into how to do that, we have to look at 2 very basic tools we need for that. The first one is GPG. And don't be scared, we won't dive deep into GPG. Who here has worked with GPG? Can you raise a hand? Okay, who has worked with GPG? And who has never heard of GPG? More interesting, cool. Don't be scared, it's actually super easy what we're about to do. GPG stands for GNU Privacy Guard. And it is an implementation of a public key infrastructure. That sounds super complicated. Implementation actually is super complicated, but the appliance is super easy if you stick to a few features. What public key infrastructure means is you can create a GPG certificate on your machine, and it will contain a private and a public key. We refer to this as asymmetric cryptography. And what you can do with this is actually quite simple. Everything that gets encrypted with your public key is only and only decryptable with your private key. That means you keep your private key very secret, and you can share the public key with all your peers. And all your peers can send information to you by encrypting it with your public key. And they can transmit it over any insecure environment, and only you, as long as you keep your private key protected, will be able to decrypt it. The private key can be protected with a password, so it's like your SSH key. You probably know, right? Before using it, you have to type a password. It's actually the same technology behind. So GPG has some more features, like digital signatures and stuff, but we really don't want to look into that. Just keep in mind, public key, private key, whatever gets encrypted with the public key can only be decrypted with a private key. If you want to get started with GPG and understand how it works and use it in your day-to-day basis or in day-to-day life, I have collected some links, and I will share this stuff by the end of the presentation. So don't bother, there will be some resources. The second tool we have to take a look at is called PAS. Has everyone here heard or seen the tool PAS? Interesting. So the developer of PAS called it, hold on to your heads, the standard Unix password manager, which is, I would say, a rather bold claim. But nevertheless, it is a neat utility. It's basically a wrapper around GPG, a very tiny wrapper around GPG. And it allows you to encrypt secret information with one or more GPG public keys at the same time, which means the information that has been encrypted can be decrypted by more than one person with their individual private keys. And the second next really cool feature is that all the secrets that are added to a password store based on pass are stored in and encrypted inside of flat files in one folder. So this folder can easily be shared using your already existing infrastructure of Git or Mercury or whatever you're using in your team, which gives you even a history. That's pretty awesome. And we will use this utility in an example application, which follows shortly, to establish an encrypted pool of secret information without relying on any shared secrets. If you want to get pass, play around with it, it's actually quite easy to acquire. It's available on Homebrew, and it's also available on all major Linux distributions. I think it even runs on Windows, but because it's a bash-based utility and GPG is, it could be complicated, I don't know. I haven't tried it on Windows, but in theory it should work. So let's start with an example application to illustrate how to do all this. So what we want to build is a status page, just pretend a status page, that interactively displays some statistics about a certain GitHub user. To do this, we will need access to the GitHub API, which is protected by an API token, which you can generate for a specific username. So the username and the API token are the shared secrets we will have to take care of. The application itself will be hosted on Heroku. Does anybody here know Heroku? Nice. Have you worked with Heroku? Anybody? Pretty cool. So Heroku, for everyone else, Heroku is a platform as a service hoster. Actually, I think one of the first who really pushed, like, today you would call it probably serverless, this idea of a platform as a service, where you don't have to maintain any infrastructure. That means your deployment works on a per application basis. That means you would deploy your jar or your var or your Ruby or your JavaScript repository, whatever. You just deploy it to Heroku, and they will run it on their application service. They do load balancing, scaling, databases. All these things just happen automatically, and you don't have to do anything with bare metal servers or virtual machines. And we use this to make the example as simple as possible. And again, if you want to get started with Heroku, I've prepared some links. We'll all get to this in the end. So the application itself is a simple JavaScript application. There's one file, index.js, and it's built on top of the Express.js web framework. You don't have to know details about the framework because the implementation is also not implemented. That's not what we want to look at, right? How to do REST calls. What's more importantly is how we configure the app using 3 environment variables. The first one is the port on which the application will listen. We defaulted it to 5000, which is kind of like a common JavaScript web server port. And Heroku will set the port variable for all the processes it forks. And the only contract you have to keep in mind is always listen on the port Heroku has set as an environment variable, and then you will integrate pretty neatly with the infrastructure. But also, this is not a secret value, right? The other 2 variables are the GitHub user and the GitHub API token, acquired on the same way as we discussed before, using environment variables. So if we would like to deploy that, this would be a simple push to the repository of Heroku. So when you create a new Heroku application, it will give you a Git remote. You add it to your local Git repository, and by pushing to that, you deploy. That's it. It's like a second remote. And in principle, this is all we have to do to get the application up and running. But we are referring to 2 environment variables, right? GitHub user and GitHub API token. that have never been configured or set in any way. This is the first push. So our application will be more or less in a crash loop, trying to read the variables and just fail horribly. Luckily for us, Heroku gives us a very easy and straightforward way to set environment variables. By executing this command, the given environment variables will be set for the application persistently, and the application will be restarted to make the change effective. And now, if we didn't have any typos in our JavaScript, the application is running, it's properly configured, and it has the private data it needs. Awesome. And this approach is already taking us in a good direction, right? We have no hard-coded secrets in our file and source code, neither in source code nor in configuration. But still, to execute this command, I have to type production secrets on my terminal, which in itself feels wrong, and also it means that every person that wants to deploy would have to type this or know this. It's also in my bash history, so there are a lot of problems associated with this. But it's taking us in a good direction. I would still say the challenge we want to solve, distributing secrets in our team, is not solved by this. So we still need a way to retrieve these information, these two very important pieces of information, automatically. So let's build a secret store. It's actually, as I mentioned, quite easy. We see that. As mentioned before, PaaS mainly operates on a single directory, which is called the secret store or the password store. To initialize such a directory, you have to set its path, obviously, and then you will call parseInit. And the only thing you have to do when calling parseInit is supply it with a list of one or more GPG IDs. GPG IDs are kind of the unique identifiers of a GPG certificate, so that PaaS knows with which public keys all the information has to be encrypted. On the command line, this would look like this. I specify the password stored here, which is a configuration variable from PaaS. I extract a GPG ID, which I can get from the certificate. It's actually pretty easy. When you generate a certificate, it will give you the ID. It's kind of a unique identifier, and this is my GPG ID. So I'm building a password store for myself. And then you just call parseInit. And what this does is it initializes a password store in the given directory, which will encrypt everything it receives, given my GPG ID. Now, adding a secret to that store is actually even easier. You just call parseAdd. That's it. PaaSadd will ask you twice on standard in for the thing you want to add to encrypt. It's like the standard password form you know from any website. And it will automatically encrypt if the two inputs match, encrypt this information with the configured GPG IDs and put it in that directory. To retrieve it again, I would call parseShow. PaaSShow takes the same path and will print the content if you are in possession of the private key, of course, one of the GPG IDs. It will print the secret on standard out. And the tool that prints stuff on standard out really just screams in your face, use me for automation tasks. So if you would take a look into this directory, the secret store directory, it would look like this now. It contains two .gpg files at the paths we specified when doing add, which contains the encrypted secret as binary data. You cannot do anything with it unless you're in possession of an unlocked private key. The GPG ID file, on the other hand, in the directory root, is the configuration of the secret store. It contains all the GPG IDs you specified doing parseInit. You never have to edit it manually by hand. Well, it's just interesting to see how little is needed get started with Pass. Of course, you don't have to use a tool like Find to look into a secret store and what's in it. You can just execute pass.ls, and we'll display you a nice preview of all the secrets that are in there. It has some more nice subcommands, and I will do a short demo in like a few minutes where you can see how it feels like to actually work with it. So the previously seen Heroku config set call, if you remember, can now be combined with pass show to enable a deployment without explicitly typing any production secrets nor using a shared password like this. It's a tiny bit of bash. The backticks mean execute this, takes a standard out, and just replace it. It's basically a replacement. So what this does is it assigns to the variable user the output of this command, which is our user, and to the token, the output of this command, and then you just call Heroku config set. But this time, just with the variables. So, of course, this is a very trivial example, but what we have accomplished with this is a secret store in a given directory from which we can retrieve those secrets, but it's only accessible by one person. That's me. Unless you have my private key, which you probably don't. But the goal was to be able to share secrets in our team. So we have another short mile to go. Let's talk about working with a team. When we talk about teams, we usually look at two different very important points in a life cycle of a team. That is rolling on and rolling off. Rolling on means that an additional person joins the trusted circle of team members. And associated with this joining is a list of privileges that are uniquely assigned to this person. It is a good idea to have something like a roll-on checklist, a security-related roll-on checklist on your project, which contains a few check marks that you can go through, like, is their hard drive encrypted? Is their SSH key encrypted? Are they using a password manager? You get the idea, like the general things that we say is a baseline for secure software development. So whenever someone joins, besides all the other tasks you have to do, like accounts, it is access to the shared secrets that need to be accessible by every team member. If we're using Pass for secret store, this is actually little effort. The only thing you have to do is get the GPG ID, but it's the public key of the person that joined, and then re-encrypt the store. That might look like this. Just pretend two people joining our team, Ada and Alan. So I got their GPG IDs, got their public keys, and I call Pass init. And that's all there is to do. What this does is it re-encrypts the secret store, given all three GPG IDs, and that's it. What changes is that the .gpg ID file now contains 3 instead of 1 GPG IDs, and everything is re-encrypted. That's what changed. Both people now will be able to access those secrets using their private keys, and we have still no shared secret, no shared well-known password, or shared private key. When rolling off, on the other hand, this is a different story. Rolling off, in a way, generates much more work than rolling on. Again, it makes sense to have something like a roll-off checklist that at least has points like, have they deleted all the source code? Are the accounts deactivated? Right, if someone leaves, we want to be sure that this person has no access anymore to our precious production, because otherwise you lose track, like who has access, who not. That's pretty dangerous. In the context of the Pass secret store, that's, well, as easy as rolling on. So Alan leaves the team, I leave out his GPG ID, and I call Pass init again. This will re-encrypt everything, with only 2 GPG IDs. It changes the GPG ID file, and that's it. But there's one very, very huge caveat. The only thing I have achieved now is that from now on, the person that left will not be able to access new secrets. But if this person, by accident or incidentally, gets hold to an old version of the password store, this person has still access to all the secrets, because, you know, if it keeps an old version somewhere, we cannot make this undone. And what we so have to keep in mind is that when someone leaves the team, we are actually obliged to change all the production secrets. That's the only way to make sure that we can control and understand who has access and who has no access. And I know this sounds like a lot of pain, do a key rotation, and it actually is complicated, or can be complicated. But since we have all the secrets in one place, using such a password store, trust me, it gets much, much easier. Really gets much easier, because this information is just in one place. Probably all your deployments based on this information. So I talked a lot about how PAS works. I've prepared a short demo, which will show you how easy it is to actually get started. So, can you read this? Is this okay for everyone? Cool. So, let's get started. We have an empty directory, and we want to create a password store. So the first thing we have to do, as I mentioned before, is export the password store dir to, I will just use the current directory, just this one. If you take a look into the variable, it's just this directory. And now I can just call pass init, but I of course need at least one GPG ID. I will just use mine. And that's actually it. See, there's now a .gpg ID file, contains my GPG ID, and now I'm theoretically done. I can do pass_ls, and it's empty. So let's pretend we have the following use case. There's a REST endpoint. It gives us a JSON, and this is password protected, right? 401 authorization required, darn. Luckily, I do know the password, but I have to share it. That's the one really bad thing. The second thing is I don't want to type it everywhere and send it via email, so let's add it to the password store. Make up a namespace here, say user. So now you cannot see what I type, which is kind of a feature. And this looks like this. User 12 is the username. And I can prove to you that this is, there's no clear text involved. If we take a look into this file, it's awful binary. No way to retrieve anything out of this. Pass has another really cool feature to add information. If it's more complex, like the password or something else, you can use pass edit. So we use this for the password. And it will just open the editor of your choice, or you can type stuff. So let's add the password. I hope I make no typo. So that's the password. Looks cool. So let's read the values out of the password store. Production user and export pass, which would be production. Whoop. Typing is hard. Like this. Now we can do curl, but instead providing it authentication like this. Oh no. Oh yeah, I mistyped the variable. Ta-da! So now we can use this in any way we want to script it. And you get the idea. I can use this utility in all my automation scripts, wherever I want to use them, be it deployment, Kubernetes deployment, Docker secrets. I mean, all these infrastructure things have ways to provide secrets to the infrastructure, but the first mile, bringing it into the tool, distributing them on the team, is not solvable with most of these tools. As I mentioned before, Parse has some other really cool, like, subcommands. For example, the grab one is kind of interesting. It grabs through the secrets and finds all the files that contain this particular string, like regular grab. So to conclude this, what have we achieved? We have built an encrypted secret store, which is living in a single directory. The single directory, comprised of solely flat files, can easily be distributed amongst your team members by, well, checking it into the same source code management system you're already using. And even if you will leak this repository, the worst case is people know which type of information you have in there, like the names of your password files, but they don't know the content. And bonus, if you add it to Git or a similar tool, you have a versioned password store, which is kind of cool. Because of the nature of Parse, the process of people joining or leaving the team becomes, well, I would say, as streamlined as possible without compromising security. It actually increases the security of your team because there's no shared password running around with which you can encrypt all the precious secrets. Instead, people have to use their private key to do so. My name is Jacob. This was my presentation about shared passwords. As I promised, there's an online version of this talk. It's basically a blog post that contains not only what I have told you right now, but also the links, which I promised you. And I'm now open for questions. There's one question in behind. If you shout, I can repeat the question. Oh, there's a microphone.
So your approach has two problems, two vulnerabilities. So if you have a big team, then you have a lot of people with probably weak security practices. So if your team is like 10, maybe 20, who have access to those encrypted passwords, it's your least secure point is your least secure member of the team. Right?
Yeah.
So again, this is one problem. Second problem is when you leave the company, when somebody leaves the company, especially if he lives on bad terms or something, you have to really change all the passwords and everything. And that person, if he lives on bad terms, probably has, if he has access to those passwords, theoretically he could have prepared his exit and leave, like, might do some damage. So if you have a real security issue, what I think is that you need a second layer of security, meaning that all the people who have access, who in your version, they have access to plain text passwords, they shouldn't have access to those. They should have access to encrypted passwords, encrypted by one or maybe two trusted members, like really trusted. And then you share the encrypted passwords with the team. They don't have any, if any member of the team loses their password or, I don't know, or are evil and try to do something bad, they don't have access to plain text passwords. And then you have 1 or 2 members who are trusted. And then, of course, you will need decryption, a second step of decryption inside the application, so such that the application would receive the encrypted password as an environment variable, same as you did on Heroku, and then decrypt it over there in the application running or something like this. Do you agree with me here?
I totally do agree with you. Can I say 2 things to your 2 separated issues?
Sure.
Yeah, so of course, I'm not advertising or advocating for sharing all the production secrets with all the team. I'm merely suggesting a first step towards establishing an infrastructure with which you can share secret information inside of your team. I just picked a very trivial example with an API token. Because what I've observed with most teams I have worked at or helped establishing infrastructure is that they're just sending passwords via email and storing them in, I don't know, a text file or somewhere. And proposing this solution is like immediately a magnitude of security, magnitude improvement security-wise without adding too much complexity. If you, as you said, move to a larger team, you most certainly don't want to have everyone access to all the production secrets, like, for example, the production database, which contains the customers. You certainly don't want, like, all developers have access to the production database. What you can do is provide different GPG ID configurations for subtrees in paths. So you can say, I have a production subtree, which contains a different .gpg ID file, so just like 2 trusted people can decrypt the secrets inside of this. There are different ways to do that. Also sharing an encrypted version of passwords and having a second layer of decryption in production is also an interesting approach to do that. But nevertheless, about key rotation, if anybody leaves the team who had access to secrets, you need to rotate them. That's just, there's no approach who can fix that. If someone had access to the secrets, they could probably keep them, so you need to change them.
Theoretically, if you have like trust 1 or 2, or I don't know, very, very few trusted members who keep the keys for the encrypted version of the secrets, then those persons can be trusted that they would have like high entropy pass phrases, and you would use some strong key derivation to build the keys to encrypt the password, such that, I mean, you can enforce good security practices on those 2, 3 members of the team. So, okay.
Thank you. Any more questions? The question from the front is, how can the distribution of public keys be handled, and if GPG can provide assistance in that? Well, there are several ways to do that. Of course, GPG has this concept of public key service, where you can automatically upload your GPG key publicly, and those are distributed like DNS. It's like a distributed network. And if you stumble upon a GPG ID you don't have the public key for, it will automatically download it from this key server. But this would require all the team members to publish their public keys, which is sometimes not intended or not in interest of the company. What we usually did is have the public keys committed inside of the password store repository in a separate folder. So you would check it out, you would then just have the public keys basically, which in itself provides new risks for which you have to protect. For example, you have to either use signed commits and a trusted person or 2 trusted persons sign these commits so that you see the public keys that are in there actually are allowed to have access to secrets. Does this answer your question? Okay. There was another question? The question was about alternative solutions like HashiCorp Vault. That is a very good question, and I would be happy to answer it. So I have used Vault in several projects. And Vault is basically like a secret store in the cloud. It can store secret information. It can also be a certificate authority. So it can do all things related to security. And it's a pretty cool tool to make secrets available to your deployments, to your services. But since it's like running in the cloud, what we usually did is we had both. Like we had Vault running in the cloud, but we treat Vault like a database. It's something that can break down, that has to be re-provisioned. So the initial values that come into Vault come out of this PaaS repository with where a few team members or administrators have access to. Does this answer your question? Cool. Anything else?
So I assume ThoughtWorks works with with clients with high security needs, and I wonder how often do they have mechanisms like this or better implemented? Because my experience with the big companies is that they lack security practices real hard. So do your
so my main or my perception of the industry is that the concept of security, especially around how to treat secret information, is a bit lacking in general. Like very often I come to a client and they either share passwords using email or have like a KeePassX file and everyone has the password to that file. I mean, you get the idea. Most companies do something like this. And for low profile projects, this is probably okay if it's not important. But as you said, if we go to high-profile industries like banking or large machine manufacturers that have connected devices, all these kind of high-profile things, these companies are actually a target. And stealing a developer laptop that's not properly encrypted is something people do because there's big money involved. And that's one of the reasons why I made this talk, is to like propose ideas that make it's actually not complicated. It's just a bit of work. But I share your perception that this in general is not taken care of properly very often. Anything else? Okay, then thank you very much.